Last episode, your agent got a memory, and that memory was a pile of numbers. Every fact turned into a vector, and to remember anything, it searched by meaning. It worked, but you couldn't open it, you couldn't read it, and you certainly couldn't edit it. So today, we build the other kind of memory, the one running most of the coding agents you already use. Plain Markdown files on disk, and a tiny index to find them. No embeddings, no vector store, nothing to pay for. Just notes and agent writes, and you can read.
There are two schools of long-term memory, and it is worth being precise about the difference. The first is what we built in Episode 5, embed every fact into a vector and search by meaning. So a question about credentials can find a note about keys, even with no words in common. The second is what we build today. Write the fact into a Markdown file, keep an index, and search the text by keyword. One retrieves by meaning, the other retrieves by words. And they cost very different things. Vectors cost an embedding call on every save and every lookup, and what is stored is a list of numbers you cannot read. Markdown costs nothing. What is stored is a file you can open, edit, and commit to Git. Neither wins outright. They fail in different places, and that is exactly why you should know both.
So here is the store, and all of it is plain files. One, a folder of Markdown, one file per topic. Billing goes in billing.md, API keys in api-keys.md. 2, in index.md, a router. One line per file saying what is in it, so both you and the model can see the whole memory at a glance. 3, a full text index. That is SQLite's FTS5, straight from the standard library. No dependency, no service. It ranks files by keyword match. That is the entire long-term memory of the agent, a folder you could zip up and mail to someone.
The agent gets two tools. The first one is remember. It takes a topic and a fact. It writes the fact into that topic's Markdown file. It adds one line to the router, and it indexes the text. No model call, no vector. Writing a memory is writing a file.
The second one is recall. It takes a question, pulls the words out of it, and asks the text index which files match best. That ranking is BM25, the standard keyword score. What comes back is the Markdown itself, the exact text a human would read. It takes about a millisecond, and it costs nothing.
And the loop around them does not change. Same React format as Episode 2. Same honesty guard, same tracer from last episode, counting every token. Only the two tools changed. That is the real lesson here. Memory is a tool you swap out, not an agent you rewrite. So let's open the code.
So in this episode, we talk about Markdown memory. It's another form of long-term memory. As we discussed in the previous session, we have short-term and long-term memory. Instead of saving everything in a database, embed it and put it in the database and then search for the most similar meaning there, we just use files. You can use Markdown files and then search like what you do in text file, Excel files. And it's why we should do it. It's cheap, as we see here. It's readable, and most agents like OpenClaw, Hermes, they use the same thing. They just put a bunch of files there as Markdown, HTML, and other formats. Now we just talk about the Markdowns, index it, and just search it. It's very fast. It's cheap since we don't embed anything. We just do a text search on the index, and then when we find it, we open the file, read it, give it as a context to the agent. So what we do here is FTS5 as index. So let me find actually the recall project, and we should have a memory here. Remember, we save a fact as Markdown. So read it, we index it, we put both text and index somewhere in the hard drive, and with the topic, with the name and index. For the recall, we just go get the text and rank files by keyword match. So we just find the most relevant files, not meaning. Here we just search word by word match. So let's actually, everything else is similar like before. Let's actually run it and see. It's the previous video. I was in the wrong folder. So let's see what happens. Just on session 1, we say every fact here, we have the chat open, so everything is on RAM, we don't forget anything. And on the session 2, we close session 1, we don't have any information about these things. So let's go and see what has happened. So I sent the first chat. Action is remember, observation is wrote, thought, and answer. It's like before, nothing has happened, just the writing into the memory is not anymore embedding, it's just indexing and putting there as an empty file. So we will go further. Session 1, all the tracings, costs, we have it here. Latencies, how many tokens, and now it comes the second session. Here are the billing.md, api-keys.md that we have, everything is saved there. So session 2 comes there. Hey, I'm back, remind me, what did I say about rotating my API keys? The action should be recalled, the API key rotation, derivation recalled from Markdown. It opens this MD, read it for the API keys, valid keys every Monday. And the answer is you said you rotate your API keys every Monday. And here is the tokens, cost, and latency. That's it. So see you on the next episode.
So that's the other school of memory. Markdown files plus an index, retrieved by keyword instead of meaning, cheap, readable, and written by the agent in a format you can edit yourself. It's how Claude.md, the agents.md standard, and Hermes remember. Vectors find what the meaning shares, text finds what the words share, and serious agents often run both. Next episode, the agent stops working alone. One orchestrator, several workers, handing tasks to each other. If this helped, like and subscribe. The code is in the description. See you in the next one.